differential length. Integral DL I was talking about. At any point, carefully check it now. At any point, rho comma phi, keeping phi constant at the given value, rho is changed by d rho. To produce a side of length rho 2 rho d rho. A side of length d rho. Listen carefully. At any point, rho comma phi, wherever it is. I'll just take it in the first quadrant when I explain it. I will produce d rho length. At the same point, very, very important now. Keeping rho constant, phi is changed by d phi. What is the length of the side produced? I am moving along a circle of radius rho. I am changing only the angle by only d phi. Actually, when I change the angle by d phi, keeping the rho constant, I will produce a straight line only, which is the arc of the sector subtending at 0 angle. What is this side? Rho d phi. Hope this is clear. Where phi is in radian. Only when phi is in radian, the arc length of a sector of radius r is r phi, provided phi is in radian. R can be, if r is in meter, r phi is in meter. If it is in centimeter, r phi is in centimeter. Dimensionally, phi has no unit. By keeping phi constant, d rho is changed by d rho. Next component is by changing rho constant, phi is changed to produce two distances. In fact, here, this actually is what? At any point rho comma phi, this is rho d phi. Now rho d phi is in meters. D rho is in meter, rho d phi is in meters. Earlier, like no A phi, capital A phi. Did I represent it as capital A phi? Somewhere. That was d phi. Now this is actually what? by keeping rho constant on the circle of radius rho, I have to move by d phi. It's a small, very small part of a circle, which is a straight line. Because of which dl bar is rho squared d phi squared. Now d phi is in radian. Very, very important. Rho is in length unit. Rho is the length. Rho has the unit of length. It can be both centimeters or both meters, doesn't matter. What is the differential length now? That's what I want you to know. Earlier, by keeping y constant, we moved by dx. It was along ax. dx, ax we put. By keeping x constant, we moved y by dy. We changed y by dy. We produced dy ay. We two mutually perpendicular sides. By keeping one coordinate constant, other coordinate is changed by differential extent. So the differential length in this coordinate system dl, whenever I want to take, is what? Root of d rho squared at any rho comma phi plus rho squared d phi squared. Now this is again on any circle of radius rho, correct? Rho is constant on any circle of radius rho. Check it properly. It can be is equal to root of 1 plus rho squared d phi by d rho whole squared, correct? Times d rho, where now rho will be changing. Phi is written as a function of rho. d phi by d rho will be a function of rho. Ultimately, everything is a function of rho. Or the same thing can be root of rho square, rho constant, plus d rho by d phi whole squared times d phi. There are limited number of cases where we do that, but we have to do this to understand at least this. Here, rho is written as a function of phi. Together, everything is a function of phi. Rho is replaced with phi function. There is one thing actually which we should know for several things actually. The structure of this particular form. Yeah. Rho is equal to A plus A cos phi. Yeah. A into 1 plus cos phi. Correct? We give such a curve. Maybe you may have to determine the length of the curve. And we may have to determine the area under this particular curve also. Chordioid. A into 1 plus cos phi. 2A it is. Correct? Cos phi is equal to 0. Phi is equal to 0, it is 2A. As phi is increased, cos phi will decrease. When phi is equal to 180, cos phi is minus 1, because of which it has become equal to 0. Again, it increases. At 90, it is A. Because cos 90 is 0. At 270, it is 0. Because it is cos 270 is equal to 0. The same way, check the last point. Differential surface element. Tomorrow we can start with these things. At any point, produce one side of length DRDO, produce another mutually perpendicular side of length rho d phi. Take the rectangle with these two sides. This area is rho d rho d. Rho d phi into d rho. Rho d phi is ds. Rho d phi is ds in circular coordinate system. And just as an example, quickly, if I have a circle of radius A, I want to talk about its area. If I want to do it in Cartesian coordinates, I will show it anyway. Not now, but next class. It will be typically a difficult one. But when I do this using this ds, at the same phi, because it is of radius A, I will take d phi and change rho from 0 to A. Integral rho d phi rho from 0 to A is this area. As rho increases, this size also will increase. Such things have to be taken from 0 to 2 pi. Integral 0 to 2 pi is what? Rho d rho is rho squared by 2 from 0 to A times. What is this? A squared by 2 into 2 pi is pi s. Check it. hey, this coordinate system, I will show that will become really extremely handy to us. Even when we talk about the problems on divergence, curl and all, these things are important. Okay. So we are into the circular two-dimensional coordinate systems in which any point P is specified by giving its coordinates rho, phi. Rho is the circle of radius rho represents, right? Phi, the radial line from origin, making an angle phi with positive x-axis. Right, this point is specified as the point of intersection of the circle and the radial line. We saw this. Given rho naught, phi naught as the coordinates of a particular point, we saw that x coordinate x naught of it is rho naught cos phi naught. Please ask if you have any doubt. Y naught is equal to rho naught sin phi naught for all phi, where rho can take the values from 0 less than or equal to rho less than or equal to infinity, and 0 less than or equal to phi less than or equal to 2 pi, measured in the definitely anti-clockwise direction because it is positive angle. So given the coordinates of the point in circular coordinate system, we can determine the coordinates of the same point in Cartesian coordinate system, and we saw this. Given x naught, y naught as the coordinates of the point, rho naught is root of x naught square plus y naught square. That can be seen from these two equations above itself. But when it comes to phi naught, it is either 2 pi plus tan inverse of y naught by x naught, substituting the values of y naught and x naught with their signs, for x naught greater than 0, x naught positive, and pi plus tan inverse of y naught by x naught if x naught is less than 0. In this, we also saw that A rho and A phi are the unit vectors, standard orthogonal unit vectors. Are mutually perpendicular for always. Unconditionally, they are mutually perpendicular. But their directions depend on where they are defined. This is what we saw. And any vector in this coordinate system is of the form A rho times capital A rho plus A phi times capital A phi. A rho and A phi will having the same units. Having the same units. the magnitude of which is root of capital A rho square plus capital A phi squared, for sure. But the angle of which depends upon where this vector is defined. Next, we defined DL bar. Now, carefully. At any point, rho comma phi, DL bar in this plane will have two perpendicular or orthogonal components. Like in XY plane, we saw DL bar is dx incrementing x by dx without changing y. Dx is produced. After that, y is incremented by dy without changing x. Here also, going through the same way, at any rho comma phi, rho is incremented by d rho. Definitely in the direction of a rho, because of which it is d rho a rho. At that particular point, if you increment phi by d phi in radian, if we increment phi by d phi, we move along a circle of radius rho by differential amount, which is a straight line, given by rho d phi here. If you change rho by d rho, straight away it is the change in the length. But if you change phi by d phi, because you have to incrementally change these values, at that particular point where the coordinates are rho and phi, we create another length component, which is rho d phi. For sure, this in radian only. Only when phi is in radian, rho d phi is the arc length of the sector. From this, we saw that any differential length dl is equal to what? Root of d rho square plus rho square d phi square. If the line or curve is defined as rho as a function of phi, rho as a function of phi, what is it I'll do? I will say that this is d rho by d phi whole square plus rho squared d phi, if rho is equal to a function of phi. Now this is completely in phi, right? This is f dash of phi squared plus f squared of phi, because rho is f of phi d phi. If phi is given as a function of rho, then I will write it as for phi g of rho. Just talking about it. It will be what? Root of rho square plus d phi by d rho, sorry, 1 plus rho square d phi by d rho whole square into d rho. Then length is always a single integral in which only one variable is independent. This is again equal to what? Root of 1 plus rho squared into g dash of rho squared d rho. While calculating the length of the curve defined in this coordinate system. Second. Then differential surface element ds is what? Again, produce one side of the rectangle by changing rho by d rho without changing phi at any point. Again, at any point. One side is d rho. At the same point, keeping rho constant, change phi by d phi, produce one more mutually perpendicular side of length rho d phi. So ds is what? Rho d rho d phi. When we are defining rho d phi, please remember, and whenever I try to integrate it, my limit should be there in radian. Only if phi is in radian units, rho d phi is the arc length. That is taken as this length of the other side in the differential element. At any point, we say d rho d phi. Produce the rectangle. Even though this rho d phi is the part of a circle of radius rho, in its d phi changing only d phi will create only a small arc. That arc can never be seen as an arc. It will be a straight line only for all cases.